Hi, today we want to consider direct variation, how we can use direct variation to solve some problems. Okay, but before that, what is variation? We know that variation it's all about the relationship that exists between two or more quantities. So for example, if you are taking fuel and then price of fares, anytime there is an increase in fuel or price of fuel, the price of lorry fare increases. This is a variation that we are talking about. But today we want to talk about direct variation. What is direct variation? Direct variation is a type of variation or relationship that exists between two or more quantities, such that as one quantity increases, the other one also increases, or vice versa. As one decreases, the other quantity also decreases. Basically, that is direct variation. So when we consider the price of fuel and then the lorry fare, this is a direct variation because anytime there is a hike in the price of fuel, there is a corresponding effect on the lorry fares. So anytime price of fuel increases, different dollar fare also increases. That is a direct variation. Okay. So mathematically, we are saying that if two quantities, say x and y, are directly related, then mathematically the rule that connects the two variables will be of the form y is equal to kx, where k is a constant known as a constant of proportionality or variation. Now, anytime we are talking about direct variation or anytime we are talking about variation, this value, the k, known as the constant of variation, it always causes that change because if the price of fuel is increasing, why is it that the lorry fare is also increasing? What is causing that change? That change is what we known as the constant of variation or that constant, that k, it causes that change. All right. Now, under direct variation, we use some statements like directly related, a statement like proportional to, and then linear to or linearly to. Now, anytime you see the statement, then we are talking about direct variation. Okay, now we want to know how we can try writing the equation that connect two or more variables. Okay, when we give you a variation statement, how we can write the mathematical equation that connects the variables in the equation. So let's consider the statement. The statement in it, the length of arc L of a circle varies directly as the radius of the circle. So as it stands like this, the two main variables are L and what? That is R, that is radius of the circle. Now, before you write the equation that connects the two variables, that is L and R, you're going to say the length of the arc L varies directly. So L varies, that's the variation symbol. This symbol is known as the variation symbol, this one. So L varies directly as the radius of the circle, so R. This is a variation statement. Now you have to change this to equation. So this is going to be L being equal to, so you change the variation symbol to equal to sign, then you introduce your constant of variation, and that is, let's say, kr. So with what you are having here, the two main variables are L, that is this one, and then the R, but the k that you are having there, where k is the constant, the constant of variation. You can use any variable of your choice to represent the k. You can use A, you can use B, any variable. The most important thing is you have to define the K. All right. So you can have L is equal to AR. In this case, your A becomes the constant of variation. All right. Let's consider another statement. X varies proportionally as the square of Y. So we are going to have X varies proportionally as the square of Y. We are talking about direct variation here. So X varies proportionally as the square of Y. So it means that Y squared. So in this case, we are going to have X to be equal to KY squared, where K is the constant of variation or proportionality. Okay, all right. Let's try this example 2. X is proportional to the square root of Y. So X, if we are saying the statement proportional, then we are talking about direct variation. So X is proportional to the square root of Y. So square root of Y. In this case, we are going to have X is equal to A square root of Y, where A is the constant of variation. It is a must. You have to introduce your constant. All right. So let's try a real example. Example 1. It says X varies directly as the cube root of Y. Full stop. When X is equal to 4, comma, Y is equal to 8. Find X when Y is equal to 64. Now with this particular question, all that you have to do is you have to get the equation connecting the two main variables there. That is the X and then the Y. If you're able to get that equation, you can find X when Y is equal to 64. So the first step, how do we get an equation connecting the two? All right. Now with this, we are going to take the statement one by one. It says X varies directly as a cube root of Y. With this statement, we are going to have the variation statement that X varies directly as a cube root. So cube root of Y. With this, we are going to have X to be equal to what? K cube root of Y, where K is the constant of variation. Okay, so with this, we have our equation X being equal to K cube root of Y. The next statement, it says when X is equal to 4, when X is equal to 4, Y is equal to 8. So with this statement, we are going to use this data to get the value of our K. It is always important because the statement given, you don't have K in the sentence there, but you have introduced the value for K. So you need to determine the exact value for the K. And the first data there is going to help you to get a value for K. So the question says that when X is equal to 4, Y is equal to 8, substitute these two values into this particular equation. Okay, so we are going to have X, which is 4, is equal to K cube root of Y, and Y is what? 8. And the cube root of Y is going to give us what? So we have 4 is equal to K multiplying the cube root of Y, and cube root of Y is going to give us 2. All right, so with this, since we are solving for K, we divide both sides by 2. We divide this side by 2. and we get 2 to be equal to k. That is our constant of variation is equal to 2. After getting this value for k, you have to substitute the value for k into this particular equation. All right. So therefore, we are going to have x to be equal to k, which we know that k is equal to what? 2. So x is equal to 2 cube root of y. And this particular equation that we are having here is the equation connecting what? The two main variables, that is the x and y. Because if you look at it, we just have x and y. We don't have k in there. The k is a value. And now we're having a value to be 2. Now we can move on to the final part of the question. It says what? Find x when y is equal to 64. Okay, so now the question say that we should find x when y is equal to 64. So we have to find x when y is equal to 64. So when you pick this equation, where you see y, you substitute the value 64 there. So we are going to have x is equal to 2 cube root of 64. And what is cube root of 64? Cube root of 64 is going to give us 4. So we are going to have x to be equal to 2 multiplying 4. We are going to get x to be equal to 8. So when y is equal to 64, x is going to be 8. That is the end of this example. Let's consider our second example. The kinetic energy E unit of a moving body varies directly as the square of its speed v meters per second. If A is equal to 800 units when v is equal to 20 meters per second, calculate the v when A is equal to 1800 units. This is a direct variation question because of the statement or the word directly. So it's a direct variation question. Okay, now what are the main variables there? The main variables there are what? A and V. All right, we got the kinetic energy E, and then what? The square of its speed V. So these are the two main variables. Therefore, E varies directly as it says what? The square of its speed. So the speed, if V is representing the speed, then the speed is going to be squared. This is the variation statement. Now let's change this to equation. So we're going to have E to be equal to, we introduce our constant. So KV squared. Now that we are having this particular equation, that is the variation equation, we need to get a value for K. We can only get a value for K if we know what E represents and what V represents. From the question, it says that if E is equal to 800 units, so it means that when E is equal to 800 and then V is equal to 20 meters per second. Now we can use these two values to get a value for our K. So using this particular equation, wherever that we see E, we put 800, and where we see V, we put 20 there. So we are going to have, therefore, 800 will be equal to K 20 squared, because the V is 20. Now we are going to have 800 is equal to K multiplying 400, because 20 squared is going to give us 400. We want to solve for K, so what do? We divide both sides by the 400. So we are going to have 800 being equal to K multiplying 400, so over 400 over 400. Now we are going to get 2 to be equal to K. All right. So after getting a value for K, what do we do next? We substitute the value for K, which is equal to 2, into this equation, this particular equation. So now we are going to have A to be equal to 2v squared. And this equation is the relation or the equation that connects the two main variables. That is, the A is equal to 2v squared, where the 2 represents the constant of variation. That is the first part of the question. Now the second part of the question says what? Calculate. So we have to calculate the V when A is equal to 1,800 units. Now the equation is A is equal to 2v squared. And the question is asking us to find V when A is equal to 1,008 units. So you have to find V when A is equal to 1,800 units. So in this case, wherever that we see A, we are going to substitute 1,800 units there. Therefore, we are going to have 1,800 is equal to 2v squared. We are solving for B. So as it stands like this, it's like making V the subject. So what do we do next? We divide both sides by the coefficient of the B squared, that is 2. And this is going to give us 900 is equal to V squared. We want to solve for B or make V the subject. So what do? We get rid of the square sign here, that is this 2. And how do we do that? By taking square root of both sides. Okay, so we are going to have square root of 900 is equal to square root of V squared. All right, and this is going to give us 30 being equal to V. So our V is equal to 30 meters per second. Therefore, V is equal to 30 meters per second. All right, so this brings us to the end of our lesson for today. Don't forget to watch the video on inverse variation. See you there.